Okay, so for closures, I want to create a new Xcode project. And it's going to be a single view app that I'm just going to call closures. And I'm going to create it on the desktop. And the first thing I want to do is set up a data object that we can kind of work against. And we can use some of those array methods that would allow us to use closures. So map, reduce, filter. I want to use that across a data set. So in order to do that, what I'm going to do is I'm going to create a class definition first. So here's my new file, and I'm going to do that with person. Okay, so person, and my person class. Let me change the font. My person class, I want to have some attributes. So I want the person to have a first name, a last name, an email, and an age. And I guess just so that I don't have to create my own initializer, I'm going to make this a struct. I don't need to make it a class. I do want to implement the custom string convertible. So I'll have a description where I return the first and last name. So here's the first name and the last name. Okay, so this is my object that I want to use, and I want to build a collection of these so that when we're working with it, we have this collection of people objects and we can kind of do things from there. Okay, so in my view controller, I want to have a collection of people. I guess I want to leave that in there so that we can kind of work from there. So I'm going to have my collection of people. It's going to be an array of person objects. And my person should have a first name. I don't know why I'm not getting IntelliSense there. So Bill, last name is Gates, email is going to be bgates@msn.com. And then the age, I don't know how old Bill Gates is, but let's make him 65. Okay, and let's have about 10 people here so we can work with this tonight. Okay, so Bill Gates, Steve Jobs, bet he's 65, similar, or was, before he passed away. Elon Musk. Yeah, I'll put him at 45. Jeff Bezos. They have to end in 5, their age. I'm running out of tech titans here. So Bill Gates, Steve Jobs, Elon Musk, Jeff Bezos. Yep, Woz. I feel like he was a little younger. Maybe not. Let's make him 60. I guess I'll make Zuckerberg. Zuck at Facebook.
Yeah.
I'll make him 30. How old do you think he is? if anyone can name the Bitcoin guy.
Oh, Satoshi?
Yeah,
Something?
yeah, that's all I know. Can't put him up there.
I only had a way to find his name. Satoshi Nakamoto. Yeah, Satoshi Nakamoto.
I'll blow the spelling here. Nakamoto. And we're going to make him a 15-year-old because no one really knows who he is, right?
Right. Picture right here, he's not 15. Yeah.
I don't think they actually know that that's him.
Yeah, or yeah, I think that's a persona or something.
Yeah, I'm not positive of that, but my understanding is that the person that created it is not like a known person. So hopefully that person cashed out of Bitcoin a long time ago. Okay, so we have some people, and I want to close this array. No, it's already closed. So beginning and ending array, couple of people. I don't know how many we actually have here, but we want to do some work with those people. Okay, so what I want to do is I want to classify people as old and young. Okay, so I have to pick some arbitrary age that's going to make them old. So, like based on our data set, I'm going to say that anyone that's 60 or over is old. Okay, so if I'm looking at this data set, like I would have Bill Gates, Steve Jobs, and Wozniak. Like those would be my 3 records that I want to show up in that result set. So before this, what we'd do is we'd have some kind of for loop, right? And we still could. And we could say, for person in self.people, we could do some kind of conditional if person.age is greater than or equal to 60, we'd keep that person, right? Or we'd push that onto some array. So we'd say we have an old person array, and we'd push that person onto an array. Is everyone good with that? So if we say, here's my old people, it's equal to an empty array, and then we want to push our person onto that old people array. And then if we're done with this loop, we should be able to print out our old people. In the tech industry, I guess 60's old, right? And empty collection, yeah. So let's strongly type this. Let's make it an empty array. Okay. So if I run this, I should be able to print out my old people. Why can't I push this? Oh, it's append, sorry. I'm skipping into JavaScript. There we go. This is how we traditionally handle this. This still works. Like this isn't an issue. I think the code's pretty straightforward, and I think we've been coding this way for a long time. So if you are a developer and you're switching over to Swift and Xcode and iOS, it's not unreasonable to write your functions this way. You'll notice that I have 3 people. The 3 people that we indicated were the 3 oldest. Works great. But we can cut down like the amount of code that we have using closures and some of those array functions that are going to be really powerful. So what I want to do is I want to leave this code in place. So this is kind of like the classic example of like how would I actually go through and say, I only want the old people. Okay, so what I'm going to do instead is I'm going to use one of the array functions. So I'm going to say let old people equal self.people.filter And then it says, you have to tell me how you're going to determine if the person that we're going through, so all these methods, the way they're going to work is it's going to iterate through that whole collection. So we have a collection of people. It's going to look at it's going to look at every single record in that collection, and it's going to make a determination, should I keep it or should I throw it out? Okay? And the way that happens is we use a closure to determine this. So what I can do is, really what I'm doing is I'm going to pass in a function and determine whether that person stays or goes. Okay, so we'll work on the syntax here because the first iteration of the syntax, I want to be really explicit about the closure syntax. So the way the closure syntax is going to work is I'm going to use these curly braces, and I'm going to have an incoming parameter. So really these curly braces are indicating that I'm passing a function into this filter operation. And the function's going to make the determination about should this thing stay or should it go. Okay, so what's going to get passed in, we know that we're iterating through each element in the collection. We're going person by person, and we're making a determination on the individual records. So we know that there is going to be an incoming parameter, and it's going to be a person. So I'm just going to have a parameter named person. Okay, so you can see the syntax gets kind of messy here. But if we really kind of parse this out, I have parentheses for the filter, I have curly braces for the function, and then I have parentheses for the parameters of that function that I'm passing in. Okay, so we're passing in an object called person. That's how we're going to refer to the current instance as we're iterating through the collection. And that person, we're going to make a determination, true or false, do we keep this thing? So there's going to be a return value, a Boolean return value. That's what the function is. So the function signature is we take an incoming parameter, which we're calling person. The return value is a Boolean, whether that person stays or goes, whether it ultimately ends up in old people. Okay, and then we have to be explicit about this. So we're going to say, okay, that's our method signature. We have a person coming in. We can even say that the person coming in is of type person, because we're iterating through that people collection. We get a Boolean back, and then we provide the actual function body. So right there is the function signature, the method signature. Then the function body comes as in, in, and here's where we define our function. So our function is going to be, we want to know if the person's age is greater than or equal to 60. If it is, we return true. Otherwise, we return false. Syntax is a mess.
It just looks like a lot more and more confusing than the original method.
It totally does, right? So we're being really verbose about this right now, right? So, and part of that is we've kind of grown to use these loops, right? So we're used to them, we're comfortable with them. If you remember back to the first time you used a loop, it wasn't that easy, right? I remember doing that in my first computer programming class, and I'm like, this doesn't make any sense. Why would I want to loop through a bunch of stuff? That's stupid. That's what I remember thinking in my head, and I'm like, oh, that doesn't make any sense.
I don't know why you'd ever do that.
Yeah. Okay, so let's just verify that this is working, right? So if we print our old people, we should end up with the exact same result. We're just filtering down saying, if this person's age is greater than or equal to 60, great, we should keep them. Okay, and the net effect is we should have the exact same people. We should have our 3 people records based on the fact that we have 3 people that are over 60. Okay, so it looks like that's what we have. Our result set's the same. Okay, so a couple of things that we can change. I don't need to type this. I don't need a data type. Here, let's actually kind of go iteration by iteration, just so we have some documentation about what's changed and what's okay to change and how we can kind of proceed to make this simpler. right? So I want this exact same thing, but I want to make it simpler, right? These if-then-elses are a killer. They're really easy to replace. Stop using them. Okay? And across all languages, right? So I want to rewrite this. So I want to return person.age greater than or equal to 60. And then I want a ternary operator, true or false. Okay, so we just went from 4 lines of code down to 1. We're saying the exact same thing. Right? Is everyone okay with that? It's basically an if-then-else. So get rid of them. And I know, if you're used to using if-then-else statements, reading this is not as straightforward as reading that if-then-else. We're comfortable with it, but it's the exact same thing. So if this condition is true, we return the true part. Otherwise, we return the false part. And in our case, our true and false part are just true and false. Okay, so again, nothing should change here. So if I run this, I have the exact same results. So we've simplified things just by changing the function definition. But that's not really anything to do with closure, right? We could have done that from the beginning of the semester on. The ternary operator is almost in every language. So I'm going to advocate that you get rid of your if-then-else syntax. Stop using it. Okay, we can change this a little bit. We can set it up so that we don't specify a return value. Swift will infer the return type. We're returning a Boolean, Swift will figure it out. Okay, so that makes it a little simpler. So we're taking a person and we get a return value. Here's another interesting thing. We don't have to type our parameter. Swift will infer it. We're iterating through a collection of people. Swift will infer that this person is of type person. Okay, so if I run this now, still looks good. Okay, here's where we can get even simpler. What's that? Let's return the result. Right? Don't need the ternary operator in this case. This closure. Whenever I have a parameter, I don't necessarily need to name the parameters. I can use the default parameters. So what's going to happen is I'm iterating through a collection, and I know that I'm going to go through each item in the collection. It's great that I'm calling it person, but I really don't need to name it. I can use a default parameter name, which is $0, and use those positional parameters. So $0 being the first parameter that would get sent into the function. So I no longer have to have a parameter. Because I don't have a parameter, I really don't need this in. So what I can do is I can just say, let's set this up so that it's a single line of code. And I don't have a person variable, I have $0. So I have a function. I know that I'm going to get an incoming parameter because I'm iterating through that collection. I refer to that incoming parameter as $0. It's positional. There's only one thing coming into that function. It's the current instance of that object that I'm iterating through the collection, right? So if we go back to our original for person in self.people, well, I'm iterating through it using a for loop. Think of this filter doing the same thing. Except instead of naming a parameter, I don't have to do that anymore. Like I'm going to have implicitly named parameters using the positions. So when we have multiple parameters, we can use $0 and $1, $2. Okay, so we run this, we should end up with the exact same result. Okay. One step further, I don't need the return. If it's a single line of code, it'll implicitly return everything. So the return's gone. And one more little bit of syntactic sugar is what they call it, is since I'm only passing in the closure, I can use a self-closing closure, meaning I don't need the parentheses around it. Filter it based on this function. And I end up with the same results. So we started with this as our closure, right? And we boiled it down to this. And I'd argue the two things are the exact same. They certainly don't look the exact same based on the syntax that you're seeing. Like they don't look the same, but they are functionally the same. This doesn't look any better than our for loop, right? Like as you were saying, looks the same as our for loop. This, like, assuming that we know how to read closures, right? Which is an assumption because it's the first time you've seen them in this class in Swift. So you're dealing with a lot of stuff here. Is a lot easier. It's one line of code. Okay. Let's try another example. Okay, so there's our old people. We could try young people, right? Like we could say, you know, I only want people under 30. Young people equal to self.people.filter. And I know, based on the syntax that we just went through, if the age is less than 30, then that's the records that we want to keep. I need it.
Okay.
Yeah, I do need it. So those are just positional based parameters. Like there is an incoming parameter. I want the parameter at index 0.
Yes, I didn't know since there was only one. You didn't have to.
Yeah, no, I do.
Okay.
I do.
And it just infers that old people and young people is going to be an array because it's already looking through an array.
So filter returns an array. Yep. Yep. And it returns an array of matched elements, so matching your function. And I decide whether I want to keep them based on this function definition.
Even if it's an array of 0 elements?
Even if it's an array of 0 elements. To be honest with you, I don't know. So if we put the age at 3, there'd be no elements in there that match that. I think it comes back as an empty array.
Can you expand on the whole $0 thing?
Yep. So it looks like we get an empty array. So like using traditional function programming, so if I said, here's a function, do something with some parameters like message, string, input, string, and our return type being void. So I don't need that. I have a function that has 2 parameters. So if I use $0, I'd be referring to the message. If I use $1, I'd be referring to input. So $0 is really functionally equivalent to message. And $1 would be equal to our input. Okay, using that syntax. That's all it is. With filter, it's not quite as intuitive because we don't actually see a function where there's an incoming parameter. but it's given. Okay, so it's kind of like your geometry class when you were in whatever 8th grade. They said, you know, here's your givens, now prove this. That's the way the filter is going to work, is I'm iterating through the collection. I'm going to give you a reference to the current element. Now do something with it. Okay, that's what this $0 is. Mm-hmm. Now, we can go all the way back though, right? Like if this doesn't look like a function definition to you, we can go all the way back to this syntax. And there's times where we want to go back to that syntax. And times where we can't take advantage of some of that stuff, like where we don't have an inferred return because we have multiple lines of code. We have to actually have an explicit return statement. Okay. Let's try. So let's say we know that we have our person class, we have the custom string convertible, which is great, but let's say we wanted to create something a little bit different. We wanted to get the first name, last name, and email and age all on separate lines. Like, so I want all of the information about each person. So again, like if I go back to view controller, it's certainly possible for me to print all of the details. So I have a for loop for person in self.people, right? I might want to print some kind of string where I grab the person.firstname and the last name and the email and the age. It's certainly possible that we want to do that. So if I run this, what we'll see is we'll have, and I guess I probably should have labeled each of those, but we have all of our data. All right, so if I want, I could say here's the first name and last name and email. And age. Okay, perfectly reasonable to do. We can just make it a lot easier. Okay, so I want to do this with a closure. Okay, and I, again, want to move myself to a more functional developer. Right, so what I can do is I can take self.people.map, and what map does is it says, I'm going to iterate through a collection, and I'm going to apply a function to each element in the collection. So our function is, we're going to print out the details of each person. Like that's what the map function is going to do. So I want to go through each element and apply some function to each element. And that function, what I want to do is just print the details of that. So if I steal this, we can use a method call even if we want to. So our map function is going to take an incoming parameter. So we'll write this out longhand again. We'll get used to this. So I want to map a function. So I'm going to pass in a function definition. That's what the curly braces are indicating. My function is going to have an incoming parameter, which is going to be an instance of a person, the current instance. Okay, so we'll have a variable called person that's going to be of type person. My function will not have a return type. So I can say that it's going to return void, but I don't need to, but I can. There's my function signature again. Now I want a function body, and normally you use curly braces for your function body. Well, we're already inside of curly braces, so you don't do it again. So what we have is that in statement. And now I provide my function definition. Okay, so what I really want to do is this stuff. And I don't have to worry about the looping convention. What this does is a little bit different than just applying that function to each element, because you're like, how is that any different than our for loop? What happens is, what happens is I get a result from this. So what's going to happen is, yeah, I'm looping through each element, and I'm going to apply some function definition to each element. But then after applying that function definition, like I can transform it. So like the classical definition is like I take raw input into my factory. Like that's what the map is think of it like a factory. I take that raw input and I convert it to something useful. Like if GM's a bad example, but if I'm a Ford factory, I take raw materials and produce cars. Like that's what this map function is supposed to do. I take raw materials, people, and I produce like formatted people. Okay? So what I want to do is I want to return this stuff. Okay? So instead of printing all of it, I want to return the whole thing. And I'm just going to use a new line. I could have done that with the prints as well. It's word wrapping on me. And then I want a new line here. I don't need space between the new line and the label. Okay, so I'm returning that. What it's going to do is it's going to give me a formatted list. Now, this is different, right? Like I'm not getting back a collection of people anymore. I'm saying you passed in people, and I'm returning a formatted string for each person. So what ends up happening is all of those people objects got converted over to a string. For each person, convert it to a string, and then build a new array of the return values. So if I now print my formatted list, what I'm going to get is, and I don't know why I'm getting this. Interesting. String literal is unused. Why do I have parens here and here? String literal is unused. I think it's my return type. I'm not returning void, I'm returning a string. If I didn't have a return type, it would have solved it for me. It would have said, oh, you're returning a string. Here's my array. I have a string, and then I have another string. All I have is strings. Like if I dumb this down, like so just so it's easier to see, like I'm just getting the first and last name for my formatted list. I don't know why the new line's causing a problem. Like it doesn't visually look nice. I'm kind of surprised it doesn't. But this is my object. So I took a person, I converted it over to a string. I might not want to convert it to a string. What if I wanted to convert it to some other object, right? Like a student. So I want a collection of students, but I don't need their age. Like let's say a student didn't need an age. So I create some new class called student. And we're going to have a struct student. And that student will have a first name and a last name and an email. And if I don't implement the custom string convertible, I'm going to have an issue. So I'll have a description as well. Okay, so this is my student class. So again, raw materials being people, my output is I want to create students from those people. Right? So maybe I have a whole basket of registrations for new students. Right? So MATC has open registration on December 12th, and you get, 1,000 registrations. Well, each one of those registrations I want to create a new student out of. So I have people. I want to create a student out of each person. So instead of returning a collection of strings, I'm going to return a collection of student objects. So here's my student, where the first name is equal to my person. I think it's equals when I'm not getting IntelliSense, so I'm having a hard time. It's colon. Person dot first name. Last name is going to be person dot last name. And email is going to be person dot email. And what I have now is a collection of students. So just to kind of prove that I have a collection of students, what I'm going to do is I'm going to say student colon. That's my description. So that when I come back over to this view controller and I've went through my collection of people and said, I want to take that raw input person and convert it over to a student object and build a collection of students, it's all done. Okay, so you'll notice I now have a collection of student objects. Raw input to finished product is really what that is. That's what the map function's supposed to do. You see this a lot, like the type conversions. Like I want to go from one object to another. Like I'll use the map function a lot for that. Really, it's meant to replace your for loop. Like people want to use the map function to replace your for loop. I don't know if I'd go that far, but this is the replacement. So again, simplifying things, I don't need a return type because it'll infer the return type. I'm returning a new student. I end up with the exact same result. I don't need the parameter name. Not necessary. So by getting rid of the parameter, I can also get rid of the in. So if I'm going to get rid of the parameter, then I have to name this, right? So instead of person, I use $.0, $.0, $.0. It's a person object because I'm going through a collection of people. And then, since I only have one statement in my function body, can everyone see that? I have the in, and then here's my function body, which is just the return. Since I only have a single statement, the return statement will be inferred. So I don't need the return statement. Since I'm using the positional-based parameters, the self-named parameters, I no longer need any of this. And since the closure is the only parameter coming into my map, so I have this map function, beginning paren, and then the closure being these curly braces, I don't need the parens. So again, we're down to a single line of code if we just allow it to be a single line of code. Why am I getting this? Oh, I do need a parenthesis here to create my student. I deleted one too many parentheses. Is everyone okay with that syntax and how it transforms? Kind of from a function definition where we have incoming parameters with types and return values, and then we run into special situations in Clojure where we don't have to specify the incoming parameters. There's only one parameter, so I can use these self-named parameters that indicate like what position. Since it's only a single line of code for that function, I don't have to have a return statement. Since the closure is the only thing that's passed into this map function, I don't need parens around the map. So like normally a map function call would have beginning and ending parentheses, and I can still have that, but it's not necessary. Like that doesn't hurt anything, it's just not necessary when the closure is the only parameter. Okay, and again, if we run this, we should end up with the exact same output, which is our formatted list. Okay, so here's our students. Like our collection of people are now converted over to student objects. I told you the syntax is screwy. Yeah, I mean, it's nice once you get used to it. And JavaScript has the exact same thing, and it's equally messy, and it does the exact same thing. So like if you learn closures here, and then you bring them over to JavaScript, like the syntax is subtly different, but it's close enough where it's like, oh yeah, the same rules apply. Like I don't have to have my parameters named if there's only a single line. I don't have to use a return statement. So like those same types of rules apply in JavaScript closures. So JavaScript and Swift are really similar, which I like because I do a lot of development in JavaScript. It's great. Okay, let's try sorting. Okay. So I want to sort this collection of people, oldest to youngest. Okay. So I want to have a sorted list. I don't even want to attempt sorting it. Right? Like if I mean, I haven't written a sort since like my data structures class in college. Like, and you write a bubble sort and it's like, oh yeah, I'm going to switch positions, and yeah, I'm never going to do it. It's always implemented in the language now, like in these modern languages. So I'm going to take advantage of the fact that it's done for me. We could have our collections implement the comparable protocol. Remember how we did that? There's an easier way using closures. Okay, so I want to sort oldest to youngest, but instead of implementing that protocol, I want to use closures to do that. So I'm going to have a variable called sorted people, and I'm going to take self.people.sort. Okay, and you'll notice that there's this person throws bool, rethrows. It's actually saying, hey, I'll do this with a closure. So if I pass this in, the way the closure is going to work is my closure is going to take two parameters, person1 and person2, or the first person and then the person you're comparing it to. A lot of people will just call those parameters A and B. Right? Person A, person B, I want to compare the two. The return value is going to be a bool, telling me which one's older or younger. And then I'll have this in, and then my function definition to write that comparison. Okay, so what I want to do is I want to just return A dot age greater than B dot age. Cannot use mutating member.
Is it sort or sorted?
Sorted, thank you. Yeah, missing my argument label. Sorted by this closure. Okay, so now if I just print out my sorted people, we should have them sorted by age. Not all that helpful to see just the name. So I want to change the description. I want to include the age next to the name. Like in parentheses, I'm going to put the age so we can see that it is sorted. Like we kind of know that it's working just by looking at these people and knowing the ages that I gave them. But if I go back over to my person, what I want to do is I want to say, you know, this person is really, in parentheses, self.age, closing parentheses. So if I run this again, now it should include first and last name and then in parentheses that age. So Gates is 65, Jobs 65, Wozniak 60, Bezos. Looks like we're sorted. If I want it reversed, right, so ascending as opposed to descending, that's easy. Just switch the comparison, right? So now we got youngest to oldest. And I didn't have to implement any protocol. So as far as reducing this down, right? Like to get rid of some of the stuff, I have two parameters. And I really, like, since this by parameter, this label is the only thing there, it's a label saying, hey, what I'm passing in is a closure. The only thing I'm still passing in is a closure. So I don't need any of this stuff again. I don't need my return statement. I don't need the parens. I don't have A and B. I have 0 and 1 in this case because I'm getting two parameters.
And that's just because the sorted function just knows it's going to have that.
Sorted takes two parameters, right? Like it's always two input values. Like I'm comparing two objects. Okay, so now when I look at these sorted people, it's going to be the exact same thing in the same order. Like I know the syntax is confusing. You're looking at it and like, I don't know if I could write that. You'll be able to write it. It just takes, like, so for me, it took me a long time to switch over to like that shorthand syntax of closure. Like, so don't worry about it. Like if you're not comfortable with the shorthand, write it out. It's a function definition. The function definition's a little bit goofy in that your function definition is always going to be in curly braces. So like my closure would be in curly braces. I would have my parameter list, param1 as a string, param2 as an int, my return type. So let's say I was going to return int, and then in this function definition. That's what a closure looks like. It's a function. So I could say, let some variable equal to that closure definition. Saying, hey, you said you were going to return an int, you're not returning an int, so let me just return 0, and that'll take care of that. It's kind of an awkward place right now. But when we're talking about closures, this is the syntax. And once you get used to that syntax, it's like, oh, like that's not a problem. I can always use that syntax. Always. It's never a problem to use that fully formed syntax for a closure. I can always use that. Okay. So I'm going to pause here. So it's 6:30. Let's break until 6:40. So I'll pause.